Yeah, hello guys. We are back again on the day 2 for the live stream on our final revision. We thank God for those that wrote today. They really enjoyed the previous live stream. So I'm here to continue the thing. Remember to ask your questions where necessary. Though I did not publish the date for this live stream, but it has become a routine that every year I do hold this live stream, free live stream to help the JAMB candidates. So these questions we are going to answer are constructed in such a way that they will help you. They will expose your weakness. Some are not regular past questions. So let's maximize the opportunity the questions will give us. And remember, your aim is not to just know that the answer is A, but you listen to my explanations carefully. Okay, so we stopped at question 14 yesterday, and we said that the answer to that question 14, which says which of the following represents the general molecular formula of alkanones, whereby we are expecting to have CnH2n plus 1 RCO, that's a CHO, but it is written in this form. The answer is option B for number 14. So we go to question number 15, which is asking us about that the current, a current of let me increase the screen. The question says that a current of 2.5 amperes is passed through a copper 2 sulfate solution for 40 minutes. Calculate the mass of silver deposited at the cathode by the same quantity of electricity supplied. So they give us that 1 Faraday is, that's a Faraday constant is 96,500 coulomb per mole. Then the molar mass of copper is 65 gram per mole. Silver is everything we need is given here. First of all, which law are we going to use? We are going to combine the first Faraday's law of electrolysis. The first Faraday's law of electrolysis is what we are going to be combining. And then in that law, the first law and the second law, is what we will put together to answer that question. First of all, we will have to write the two elements. How will you know when second law is involved? We have two different, we are talking about copper, we are talking about silver with different charges. The magnitude of charge on copper is +2, that of silver is +1. And second law is trying to tell us that the higher the charge, the lesser the moles discharged, which means we will have more moles of silver than copper because we have the charge on copper is higher than that of silver. You can endeavor to watch my video here on the second Faraday law on the cheat on how to do the calculation. But here I'm going to use the normal style to solve it. First of all, we go with the element given to us. The one they gave us clearly first is copper. So the half cell equation is copper 2 ion plus 2 electrons to give us copper. This implies that 2 moles of electron require also 2 Faradays to give us 63.5 grams. That's the molar mass of copper. And this implies, remember that 1 Faraday is 96,500 coulomb per mole, such that 2 moles of Faraday will now be what? 2F will now be automatically 2 times 96,500, which will give us 193,000 coulombs. So it's already known now that 193,000 will give us automatically 193,000 will give us 63 grams of copper. Then we continue. This is now a known fact. 193,000 will give us 63.5 grams of copper. And then, so yeah, I can see you there. Thank you for the thumbs up. Yeah. So we now see we go to the quantity provided. They told us that quantity, the formula is current times time. And in this case, the current provided from the question, let's look where 2.5 is the current. So 2.5, and time was 40 minutes, but time must be in seconds. 1 minute is composed of 40 seconds. Therefore, we are going to have 40 times 60, by 2.5. At the end, the quantity here is 6,000 coulombs. That's the quantity supply. Then you ask yourself, 193,000 was able to discharge what? 63.5, or was able to discharge 1 mole of copper. You can change this mass here to mole. So I say let's go with mole so that it will be easy. We wouldn't require to go further. This implies that 193,000 will discharge 1 mole of copper, such that 6,000 will now discharge how many moles? We cross multiply. 193,000 x is equal to 6,000, such that x is equal to 6,000 divided by 193,000. From the calculator department, we have that. For those online, please, it will be good if you give thumbs up to this and then share this link to help others also. This today, those that wrote today, they were able to testify very well. So we have 6,000 divided by 193,000, 0.031. Okay, so this gives us 0.031 moles of copper. So we have gotten the moles of copper, but they are asking us the quantity, the mass of silver deposited. So since we have gotten the mole, we now take the inverse. According to the law, we have Ag plus and Cu2 plus. This implies that if 0.31 moles of copper is discharged, it implies that what will be discharged here is times 2, is 0.31. Remember to ask your questions for those of you online. Okay. So sorry for the small break. So we have that this place will now be 0. If 1 mole of copper is discharged, it means that 2 moles of silver will be discharged because of inverse proportion. So we go by the number of moles of this should be 0.31 times 2, which will give us 0.62 moles of what? Silver. Then the molar mass of silver is equal to 108. Then we use the formula which says that mole is equal to mass all over molar mass. And what is the mass we are looking for? That's the unknown. We have our mole already, which means 0.62 is equal to mass over what? 108. Therefore, m is equal to 0.62 times 108. So 0.62 is 0.62. No, should that be times? I think there is a mistake somewhere. No, it's not times, it's divide, please. So mass is now equal to, no, it should be times. Where is the error coming from? 0.31 times 2, of course, will give us 0.62. Then mass, let me check the solving here again. 6,000 divided by 193,000. Oh, 0.062. That's where the error is from, please. This is from here 0.062, which is 6.67. Okay. Sorry for the mix-up. I omitted one decimal point, and that will multiply the answer by 10, of course. So here is, over here is 0.031, so that of saver will be 0.031 times 2 to give us 0.062. Using N equal to mass over molar mass, we have that 0.062 is equal to M over 108, so that the mass discharged is 0.062 times 108. All right, we go to the calculator and check. 0.062 times 108 is 6.69, which is that 6.7. That's option B. So the correct answer to question number 15 is option B. Then number 16 says, which of the following is not a carbonyl compound? First of all, we are into question number 16, and the term there is carbonyl. What do you mean by carbonyl? Carbonyl compound is any compound that contains this as a group, C double bond O. Any compound that contains that is seen as a carbonyl compound. So, which means CO2 itself, structurally, look at what CO2 is. If you draw the structure of CO2, you will get so carbon 4 oxide, which is the first option, is CO double bond O. So with this, it is obvious that it contains C double bond O. So any compound that has C double bond O is a carbonyl compound. So this implies, we go to the next one, fructose. Fructose is also called, another name for fructose is a non-reducing sugar because it contains the ketone. So it's called ketose sugar. While glucose is also known as aldose sugar because it contains the aldehyde functional group. This implies aldehydes have H, a question under ideal gas law. We have done that. You check our live stream yesterday, the first day live stream. We did that under ideal gas, PV equals nRT. That was question number 3, if I'm not mistaken. For that person that asked, look at it here. You see the ideal gas. So please endeavor to watch the first live stream. You get the answer to what you are looking for, okay? Or if you have anyone you can send here, I'll solve it for you. Do you understand? Okay, so when we say aldose, that's for glucose. Glucose have this C and double bond O. Then this means it is a carbonyl compound because this is the compound we are looking at. Then this fructose now have C double bond O without extra H, so it's a carbonyl compound. But isopropyl alcohol means propan2-ol. Look at it here. There is no C double bond O. Therefore, the correct answer is option D. It is not a carbonyl compound. Other carbonyl compounds include esters. Esters are also carboxylic acids are also carbonic compounds, because when we say carboxylic acid, they contain COOH, which when you draw is C double bond O and OH. This automatically makes it a carbonyl compound, all right? So, and the general characteristics of carbonic compounds is that they undergo addition reaction, okay? Then, which of the following, number 17 says, which of the following molecule has an octahedral shape? You can use isolation to answer this question 17. Octahedra, we all know that ammonia is trigonal pyramidal, methane is tetrahedra, and water is bent, angular, or V-shaped. Therefore, the one we, even if you don't know that sulfur hexafluoride is octahedra, you will use isolation to answer it. So the correct answer to question number 17 is option A, sulfur hexafluoride. It is octahedra in shape. Then remember, most of the alkane family are all, when the name ends in "ane", if they are calling it and the name ended in "ane", I think I want to use this, okay. You can choose black with contrast better. Right, so the answer to that one, sulfur hexafluoride, is octahedra. Then I'm talking about anything that have ane, maybe ethane, tetrahedra, propane, tetrahedra, okay. Water is bent. So watch my video here on molecular geometry to see more of other shapes and the reasons why they exhibit what they exhibit. The other one says, which of the following stains can be removed? Of course, turpentine is used in paint. So the correct answer to question number 18 is C, paints. So most times we use turpentine as thinner in paint. Then number 19 says, if 450 cm cube of air is passed through alkaline pyrogalol, the volume of air remaining is, they say 450 cm cube of air is passed through alkaline pyrogalol. First of all, alkaline pyrogalol is used to remove or absorb oxygen. Removes oxygen from mixture of air. That you know that air is a mixture on its own. So if you pass air through alkaline pyrogalol, it removes oxygen. Other alternatives that can be used to remove oxygen include, you can also remove oxygen using heated gold or heated copper. So these three things remarkably absorbs oxygen. Therefore, if they tell us that they pass air through alkaline pyrogalol, we should also know that oxygen has been removed. Now, the percentage of oxygen in the air is what? We have to take that into consideration. What is the percentage of oxygen in any sample of air? It is 20 to 21%. But for this example purpose, please use 21%. Therefore, what volume of air? What's the volume of air provided? Volume of air provided from the question 19 is 450 cm cube. So your job is just to say 21% of 450 is equal to what? At the end, we will get approximately, let's check, which is the same thing as 0.21 times 450. From the calculator department, we have that, okay, this is still here, 0.21 times 450 is 94.5, of course. So we have 94.5 what? Cm cube. Therefore, this is the volume of what? This is the volume of oxygen removed. The air has reduced by 94.5 was removed, but they say calculate the volume of air remaining, which means the one remaining should now be the total minus volume of oxygen, and total is 450 minus 94.5, which will give us, maybe I'll just say minus 450. The answer here is 355, okay? 355.5. 355.5 cm3, which is option B on approximation. So we move to question number 20. If the change in free energy of a system is minus 899 joule per mole and the entropy change is, let's all read it together, that the change, so you look at the question well, you are required to use the Gibbs free energy change. Please, you listen to my explanations well, not just the final answer. Okay, so I think we go up here, continue over here. We have that we are going to use this formula for question number 20. Is that 20? Yes. We are going to use change in free energy is equal to heat change minus temperature times change in entropy, and they are looking for change in heat. They told us that change in entropy, change in free energy here is minus 899 joule per mole. Be careful about units here, because sometimes they will give one in in joules and give you the other in kilojoules. Endeavor to convert. Don't solve kilojoules and joules together. No, it's just like solving in gram and kilogram. You must convert. Be careful. These are the traps they set for you. You failing what you know. So we replace change in heat, that's change in change in free energy as minus this, which is now equal to heat change minus, they gave us temperature, which is 250, and then is in degrees. We have to change it to Kelvin. So 250 degrees is equal to 250 plus 273 in Kelvin. So if we do this, 250 plus 250 will give you 300. We have extra, that should be 4, I think 423, but let me, no, 5 or 623. 250 plus 273 is 523. Yeah, so 523 Kelvin. So we are going to place the temperature here as what? 523 times, what's the entropy? They say that the entropy change is 10 joule. See what I'm saying? It is 10 joule per mole. 10 joule per mole per Kelvin is in Kelvin already. That is what is mandating us to use the temperature in Kelvin also. And this one is also joules. If you see a situation where this joule is kilojoule and this particular one is in joules, no, you have to convert. So we now say times what here? Exactly. So by so doing, we now have that minus 899 is equal to heat change minus 5230, meaning this is times 10, and you get what you are looking for. So that our heat change now, remember this remains where it is, which is minus 899, and here is crossing now, becomes plus 5230. So from the calculator department, plus minus 899 plus 520 is the same thing as saying 5230 minus 899. That will give us 4331. Okay, we move on. We said number, please, the correct answer to question number 20 is option C, plus 4331. All right. Number 21 says 16.55 grams of lead 2085 was dissolved in 100 grams of distilled water at 20 degrees. Calculate the solubility of the solute in mole per dm cube. This is solubility in mole per dm cube. You can use the majestic shortcut to solve this question. You can simply just say that solubility in moles per dm cube is equal to 1000 times mass given all over molar mass divided by volume given in cm cube. And we should remember that 1000 grams of distilled water is also equal to 1000 cm cube. It's the same thing because the density of water is 1 gram per cm cube. So we can use gram as for volume since water is concerned because we already know the density of water. All right. So looking at this, what is the mass? Our mass given here is 16.55. Lead 2085 is PB bracket NO3 bracket 2. The molar mass is 331. One of the ways to survive chemistry calculations in the hall is to know molar masses of most compounds like lead 2085. If you go to hall and you want to really calculate this, you might make mistakes in your summation, and that is where your problem starts. So you see how I just say lead 2085, I already know it's 331. Aluminium tetrazosulfate 6342. Calcium carbonate, calcium tetracarbonate 400, sodium chloride 58.5, carbon dioxide 44, H2SO4 98. You need to know them this way. It will save you time. Sodium tetracarbonate 4 is 106. Sodium tetracarbonate 4 decahydrate is 286. So these are the signs to avoid wasting too much time, okay? So with this, we have now, from the formula I stated, so that mole per dm cube is now equal to 1000 times the mass given is 16.55 all over molar mass, which is 331, all over volume given, they said was dissolved in 100 grams. So this 100 grams of water is our volume. 100 grams of water is the same thing as 100 cm cube of water. So we can equally kill everything and then cancel. We are now left with what? 10 times 16.55 divided by 331. So which is also the same thing as say 165.5 divided by 331. 165.5 divided by 331. So when we look at the calculator, 165.5. Okay. So please, can you solve a question? Okay, I've read that one. Thank you for the sign. Divided by 331 is equal to 0.5. So 0.5 mole per dm cube. 0.5 mole per dm cube is our answer. So the correct answer to, you're welcome, my dear. Share this link now. Yeah, trying. Thank you for those online. Some are coming and going. I know that's a network issue, but you guys are wonderful. Please, we cannot grow without your help. So expand the science community. I'm doing this to help out academically in science. So your job, it is either you are the candle producing the light or you are the mirror reflecting it. If God have made me the candle for now, can you be my mirror? Be this channel's mirror. Share this video. Tell your friends about this channel. Don't hide of the thing you are benefiting. Let others benefit from it. Do you understand? I know people pay heavily to access this type of club, but now I do it every year to help Nigerian students to gain admission, to study, especially science. But I pray one day they will study science not just for certificates, but to apply it. All right. We move to question 22. The question 22 says that D to D transition observed in most transition metals are responsible. So this is a kind of a bit advanced, but it's not too advanced. I purposely constructed these questions to open your eye in some of the little advancement to chemistry. So in D orbital, D subshell has how many orbitals? D subshell has 5 orbitals. 1, 2, 3, 5. 1, 2, 3, 4, 5. Okay. Okay, I wish you the best of luck. Of course, of course. You will succeed, just like your friends have done also. So the D shells has the D subshell has, not D shell, please. We call this thing subshell. D subshell has 5 suborbitals, and out of these 5 is divided into lower and upper D, which means if anything there is what we call D to D transition, meaning if electron move from here to here, that's within that D is moving from lower D to upper D, it leads to emission of some. You remember what we call, I don't know if you know about spectral line emission. Whenever electron changes its position, either going down or going up, it either absorbs or loses energy. If you move from higher to lower, you emit energy. Do you get that now? That's spectral line emission. But for you to go from lower to higher, you have to absorb. So when there is D to D transition, if the one that is upper here goes down to occupy this place, there will be emission of some kind of energy, which has what? A certain wavelength. So the correct answer to number 22 is C. It gives them color. So remember, we see color based on the one absorbed and the one reflected. The color we see is the part of the light, white light, that is reflected. If you are seeing yellow, it means that that object is reflecting yellow but absorbing other colors of the white light. That is the fact there. If you are seeing black, black absorbs every color. It means it has absorbed all the colors at all wavelengths. But if you are seeing white, it means such substance, like you are seeing this screen is white, is reflecting all other colors of different wavelengths of white light. Okay, so that's the correct answer to 22 is C. Now we move on. This one says, which of the following, I don't know how long we have spent. This is supposed to last just, but okay, this is 33 minutes. I'm ending in the next 7 minutes or so. Ask your questions if you're online. This one says, which of the following, remember I've uploaded these questions and the summary of their answers, but what matters is this explanation I'm giving now. Which of the following equation represents artificial transmutation? Artificial transmutation is just changing one element to the other. Don't confuse artificial transmutation with nuclear fusion and fission. Turning one atom entirely to the other is artificial transmutation. So looking at option A is the correct answer because that is even the first artificial transmutation carried out by Ernest Rutherford. So the first person to carry out artificial transmutation was Ernest Rutherford. So option A, he transmuted the nitrogen atom to oxygen. You see, you have converted nitrogen to oxygen by bombarding it with water. The helium or hydrogen here to give you this. So, but remember that in artificial transmutation, what matters is that you use one basic particle, one of the elementary particles, to give you another elementary particle. Even though we have here 14, this 15, so there is this 0 is 1. There is an error here, please, during typing. Because if you check this, it did not balance. This is 14 plus 1. Okay, yeah, 15. It's still okay, but neutron is not 0, 0. So I didn't balance this well, but that's the most suitable answer here. This one is alpha decay. Option B is alpha decay. All right. So we go to the next question. So to round up, 24 says, calculate the volume occupied by a gas collected over water at 10 degrees and 790 millimeter mercury if the volume of the gas at STP is 230 cm cube, SVP of water at 10 degrees equal to 8 millimeter mercury. SVP means saturated vapor pressure. So the saturated vapor pressure of water at that particular temperature, which is 10 degrees, is 8 millimeter mercury. Now, what are you going to use here? Even if you don't understand it well, immediately they give you SVP in brackets. Am I talking to somebody? You are going to be using general gas equation, but you are going to combine it with Gay-Lussac's, is that Gay-Lussac? No. You are going to combine it with Dalton's law of partial pressure. If you, only that we are mostly based on theory, what we are talking about is when you prepare gases in the laboratory, you collect gas over water. Whenever you collect gas over water, you can check from my videos here. I'm not only doing tutorials, I do science. I have many experiments here, but unfortunately, Africans don't like experiment. They only like WAEC, JAMB, their semester exam, but on check some of these videos. If you want to learn science, Her Majesty's World Science channel is good for you. There are a lot of experiment demonstrations that you might have, your school might have not shown you, probably because the knowledge is not there and we don't actually care. If you are collecting gas over water, most times we need a beehive shelf, which I wouldn't know if you understand what I'm saying, which will support the receiving jar, which sometimes the receiving jar you can invert a measuring cylinder. So if you invert the measuring cylinder, you can now connect your delivery tube. You see this drawing most times in your textbook. Yeah, that's the drawing I'm talking about. This type of thing, there will be water. Now, if you are collecting this gas over water, what it implies that water vapor also comes alongside with that gas. So we have two mixtures of gases now, water vapor and the gas in question, and then the gas being collected. The gas being what? Collected over water. So, and hydrogen doesn't, for example, most gas is collected over water don't react with water. If they react with water, you cannot collect it over water. I've seen it like if it is soluble in water, you don't collect it over water. And Dalton's law says that, Dalton's law of partial pressure says that when two gases that do not chemically combine together, in their mixture, they will exert a total pressure, which is determined by the individual partial pressures of the gases that makes up the mixture. So in a gaseous mixture that do not chemically combine together, that the total pressure exerted by the gaseous mixture is equal to the sum of the individual gases. So we have that P total is equal to what? PA plus PB plus PC and so on and so forth. So this is total pressure, that the total pressure is equal to, if this is when this mixture is made up of gas A, gas B, gas C. Remember, the condition is that these three will not chemically combine. But here we are seeing only now P total, which is partial pressure of the gas collected over water plus partial pressure of water vapor. Am I talking to somebody? And the P total was given to us. We are into question number 24. Yeah. The total pressure is the exact pressure here. That's 790. So here we have our 790 equal to the pressure of the gas plus pressure of water. And the pressure of water is the saturated vapor pressure. So we have to find the actual pressure of the gas. And this implies that 790 millimeter watts mercury is equal to the partial pressure of the individual gas plus now 8, such that the real pressure of the gas being collected over water is now 790 minus 8. Simple. If they give you saturated vapor pressure, they give you saturated vapor pressure, just minus whatever that is given to you to the pressure mentioned. If you don't understand what I'm saying, just 790 minus 8. 790 minus 8 is automatically 782, if I'm correct. So 782 millimeter mercury. You now go back and use your P1 V1 over T1. That's general gas equation, equal to P2 V2 over T2. And so doing, please, those of you online, help like this and share it, or even though we are ending, but I'll save it. When I finish now, it automatically saves. P1 V1 all over T1 equal to P2 V2 all over T2. Now, what is our P1? We are looking for, they said, the question is calculate the volume occupied. So we are looking for V1 actually. We don't know the first volume. Thank you for liking. We need you to also subscribe. Check my previous live stream here. If this have helped you a lot, please endeavor to testify. Invite me on your matriculation. Let me sound optimistic. Happy matriculation to you guys. So let me now move on. We have our P1. P1 here is 782. Don't use 790. Remember, JAMB will place option where if you mistakenly use 790, that's the temptation, times V1 all over the T1 was 10 degrees, and 10 should be converted to, degrees should be converted to Kelvin. Always work in Kelvin. 10 plus 273, to convert degrees to Kelvin, you need to add what? You need to add 273. So 10 plus 273 is equal to 283, correct? Then equal to what? P2, they said at STP. They gave us volume at STP. And ST means standard temperature, which is 273. Then SP means standard pressure, which is 760 millimeter mercury. And here we move. Remember, 760 millimeter mercury is equal to 1 atm, which is also equal to 101,325 Newton per meter square, of course. Now, our P2 is 760. Remember that P2 must not be 760. It depends on how the question was coined. If STP was mentioned first, I might say at STP, a 230 cm, a gas has a volume 230 cm cube. Calculate the volume at 790. You see it now. This time around, that means your ST is your T1, SP becomes your P1. So it depends. If STP was mentioned last, you now make it your P2 T2. But when it is mentioned first, it can now become T1 and P1. So there is no such thing that STP is usually P2 and T2. No, it can be. It depends on how the question is coined. So here, according to this question, because they said it's collected over water, I mentioned the temperature and another one first. So I made STP second time. So this is my P2 T2. So times V2 is 230, which was given, all over T1, which is 273. Because of time, V1 will now be 760 times 230, if I'm correct, times 283 all over 782 times 273. If you do this, you will arrive at 231.8 cm cube. But if you use 790 here, you will get 229, which is option B. I purposely did it that way. Okay, so that, and JAMB also does that. We wouldn't say it's wickedness. That's why if the answer is option A, look well before you conclude. They now say, when ethanamide undergoes strong oxidation, which of the following is formed? Ethanamide, earth to earth. Ethanamide undergoing oxidation gives you ethanoic acid. Simple. So the correct answer is option B. This one don't need much explanation. We go to number 26. What is the byproduct formed during the condensation polymerization of nylon 66? Nylon 66. So I have to explain so that in case anyone comes, we'll be able to answer. The key term we are going to consider here is that we said condensation. We have two types of polymerization and two types of polymer depending. We have condensation polymerization and addition polymerization. I hope you can hear me over there. Condensation polymerization and what? Addition polymerization. So in the two types, what matters is that the second one, I simply use the word GIGO, garbage in, garbage out. Nothing is lost. What you added is exactly what you will get. For example, if you say polyethylene, Polymerization is the linking or joining of simple molecular weight compound known as monomers to form giant molecules known as polymers of high molecular weight. Okay, just like in your house, the walls in your house is made up of blocks. So if you join blocks together, you make a wall. So the block is a monomer, which is what you repeat. You keep repeating those blocks to make up what? A giant part of block, which is now wall. That wall is now a polymer. That's the idea in chemistry, meaning this is, are you getting this? Building, this is block. Each of these block is called monomer. So the process of joining them to get a larger molecule in a complex way is called polymerization. All right. Now we have two types of polymerization. In the condensation, there is elimination of small molecule of water. Elimination of small molecule. Small molecules are eliminated. I want to use simple condensation reaction, though it's not other polymerization. Watch me. Condensation of two simple sugars will lead to loss of some small molecules. For instance, we have C6H12O6 plus another C6H12O6. Normally, if this is addition polymerization, addition means you add up, nothing is lost. The exact thing you invested is the exact thing you get. Just like addition reaction. Remember, in all addition reaction is only one product that is formed and no mass is lost. So we see that this is additively, this is 6 plus 6. It should now be C12. H12 plus 12. This is assumed though, but this is incorrect. 6 plus 6 should be O12. But unfortunately, this is if it is addition polymerization, but we don't have it, which means in real sense, this is not the product. I remove it to tell you the correct product. The correct product is that there will be loss in small molecule. Water will be minused such that how many carbons are there? 6 plus 6. We still have C12. But hydrogen, we have 12 plus 12, 24 minus 2, so that it will become 22. And we have 6 plus 6 minus 1 oxygen. 6 plus 6 is 12 minus 1 oxygen gives you 11. So this is a good example of condensation. So in condensation reaction, small molecules are lost. Small molecules, note it for exam, commonly HCl, ammonia, or equally what? Water. So these are the common small molecules lost during condensation polymerization. And if you look at this option, it has only one out of the three I mentioned, even when you don't know. This question I have taught you that nylon 66 is a condensation polymer. Do you understand now? It is formed. It is not garbage in, garbage out. The total product, polymers are less than the constituent monomers that makes it up. Am I talking to somebody? So you know that glucose should be 180. 180 plus 180 should give us 360. But the sucrose is not up to 360. Sucrose is less than 360. If you remove 18 from 360, you get the answer because water is lost. So the correct answer to question 26 is option B. In addition polymerization, nothing is lost. For example, if you say 3 molecules of ethyne, C2H2, if we polymerize this, it will give you C6H6. This is pure addition because 3 times 2 is 6, 3 times 2 is still 6. Nothing is lost. This is pure addition polymerization. Nothing is lost. Okay, I'll take the last question for this live stream. I've given extra time. I'm supposed to stop 40 minutes. Which of the following is formed by the condensation polymerization and requires the elimination of water as a byproduct? This one now asks you reverse, almost related to 26. Okay, they are asking you for condensation polymerization. I want you to note something about this option. What I want to teach you about this option 27, of which you will apply in exam. You apply this thing I want to teach you when you don't know answer, when you don't know what to do again. Look at the whole option. Every option have poly, 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 except B. If I'm the one, I'll go with that one that is too unique and off. I'll ask you, why are you like this? Me, I go choose you. So, but the answer is still bakelite. So bakelite is the first artificial or the first synthetic polymer produced in chemistry. So bakelite is the answer. Bakelite is the only condensation polymer here. All others here are what? Addition polymers. So the only thing I will tell you here is that most addition polymers are named using poly. Polyvinyl chloride. What is the monomer? Just remove the poly and say the thing remaining. The monomer of polyvinyl chloride is vinyl chloride. Vinyl chloride means chloroethene. Do you understand that? So now the other one, polystyrene, is addition. What is the monomer? Just remove poly and say styrene. So styrene is the monomer. Then how about option D? Polyethene is an addition polymer. We all know polyethene. When we call it polyethene, we forget. But how about polythene bag? Polythene bag. Polythene bag, that's it. That polythene is gotten from polymerization of ethene. Is an addition polymer. So bakelite is the correct answer. So their names are not usually, we don't usually use poly for them. Why? Why don't we use poly for them? Because what I said now is, if you remove poly, you just get the monomer. But condensation polymers have more than one type of monomer. Am I talking to somebody? Polyethene has only one monomer, which is ethene. But if you say nylon 66 here, it has more than one type of polymer. And when you say any other bakelite, it has also more than one type of monomer. So different monomers join together to form it. So thank you guys for coming. I wish you guys the best of luck. Don't mind what you saw at the thumbnail. It's just to make you come in and join the class. I believe you have learned a lot. God bless you for me, and then congratulations in advance. Much love. Stay majestic. Please share, like this video.